Welcome to this FP1 lesson on sums of squares and cubes. So we've already looked at the sum of 1 and the sum of r. Now the sum of 1 was a linear expression, the sum of r was a quadratic expression. So if this pattern kind of follows on, the sum of r squared will be a cubic and the sum of r cubed will be a quartic. Okay, now these formulae you can just use. However, when we get into the final chapter in this unit, we'll look at proof by induction, and these can be proved using mathematical induction. Okay, but we'll talk about that in a later video. So here are my formulae. So r squared is 1/6n, n plus 1, 2n plus 1, and r cubed is 1/4 n squared, n plus 1 squared. Okay, now you can prove these with using mathematical induction. That'll come in the final chapter of FP1, so I won't dwell on that now. For now, just like in the last video, it's a matter of using these formulae just to solve simple problems. Okay, this shouldn't be too difficult, and I think the best place to start is with the first example. So here's my example. Now, starting with part A, sum of r between r equals 1 and n, r plus 2, r plus 5. Then what we want to do is expand. So this is going to give me r squared plus 7r plus 10. So this now is being split up into r squared plus 7, the sum of r, plus 10 times the sum of 1. And now it's a matter of using my formulae. So this first one is 1/6 n plus 1, 2n plus 1. So plus 7 times a half n plus 1 plus 10 times n. Now it should be a matter of expanding and simplifying. So we've got 1/6, and then I've got n times 2n squared, n and 2n, 3n plus 1. And of course I can get rid of my bracket here, and this n and this will be squared, will become cubed, this will be squared, and that will be n. 7 over 2 n squared plus 7 over 2 plus 10n. I'm sorry, that is in brackets multiplied by 1/6. Now we've got up here a third. So third is what's got to come out. So I can think of taking a third out of these and then seeing what we are left with. And I could also take out the n, but for now I'll just multiply through by the 6 so that we can get this into something, you know, a little bit nicer. Oh, sorry, this should be an n with this 7 over 2 there. Okay, so n cubed over 3, that's going to stay as it is. N over 2 plus 7 over 2, n squared over 2, this one here, plus 7 over 2 n squared, so that's a half plus 3.5, so that's going to be 4 n squared. Then I've got 1/6 n plus 7 over 2 n plus 10, and that gives me 41 over 3 n. So then the final step is to take out a third n, and that leaves me with n squared plus 12n plus 41, which was as we required. Okay, so it's up here. It's a nice straightforward part A. Now part B is just using that, isn't it? So sum of r equals 10 to 50 of our r plus 2 r plus 5 is the sum of it from r equals 1 to 50 minus the sum of it from r equals 1 to 9. So now I can substitute it in. So 1/3 times 50 times 50 squared plus 12 times 50 plus 41 minus 1/3 times 9 squared plus 12 times 9 plus 41. This is 5, 2, 3, 50 minus 690, and this is 51660. Now we can check the answer in our calculators just using the sum button, and then obviously putting in the original one but with x instead of the r. So x plus 2 brackets x plus 5 brackets, and then it's from 10 to 50, and there you see it's 51660. So exactly the same. So it's always worth, you know, just using your calculator to double check your answer at the end. Now, I won't do any more examples because I think it is quite straightforward. So I'll pick out a few past exam questions on this, and then I'll go through those at the end so that, you know, if you have any more questions, you can look at the actual questions and solutions rather than another example. Okay, so have a go at those. Now, if you watching up to this point and you found this video useful, don't forget to hit like. If you have not yet subscribed to my channel, please do subscribe. Okay, you know, if you're finding this video useful, you might find some of my other videos, and subscribing helps me, doesn't cost you anything, and helps you able to find the channel again. Also, you know, if you're a long-term viewer and you have found my content useful, please consider joining, even if you just join for 1 month. It really helps me out and enables me to make these videos. Now, without further ado, let's look at the first 4 questions. So here are the 4 questions. Please feel free to pause the video at any point, and shortly we will get into the answers. Okay, this first one is just a straightforward evaluate. So what we want to do is that r squared we want to turn into 1/6. Oh, sorry. Let me just separate these out first so that we do write it out properly. But yeah, the r squared into 1/6 n plus 1 to n plus 1, and where n is 30. So we're substituting 30 in. So 30 plus 1, and then 2 times 30 plus 1. And then that is minus n, which is 30. So we've got 1/6 times 30 times 31 times 61, and then we're going to take away 30 at the end. And that gives us 9425. And then checking it in my calculator. So that is sum, and then it's r squared minus 1, and it's from 1 to 30. And 9425, so that is the right answer, and we can move on. Okay, question 2. So we've got this between r equals 1 and n for r squared plus 3, and then the sum of r plus and the sum of 1. So that is what we're looking at. Now r squared is 1/6 n plus 1 to n plus 1, and r is 1/2 n plus 1, and then 1 is just n. So this is what we've got and what we've got to simplify here. So easiest thing to do now, normally I go, yeah, let's expand it, but have a look up here. We've got it in brackets. We've got a third on the outside. If I'm looking down here, we've got an n, an n, and an n, and there's an n outside. So I can certainly do that. And then we've got this 1/3. So this is a 6. If I take a third out, it's going to be like 2 times it. This is obviously 3/2. So it doesn't really play into my third, but we can make it work. So if I'll take an extra step just to show you what I'm doing. So I'm doing a third times now this first bit, or let's call it a third n. Okay, so that's what I'm basically going to take out. Now if I take a third out of the one that says 1/6, then that's going to leave you with 1/2, because a third times a half is a 1/6. So it's 1/2 n plus 1 to n plus 1. Okay, plus, and then it's going to be 9/2 n plus 1 plus, and then it's going to be 3. So keeping my third n outside, I'm now just going to expand everything because I was looking for like a shorter cut, thinking that n plus 1 appeared in two of them. Maybe I can get it into the last one. I think it is possibly going to be an n plus 1, but let's expand and simplify. So we've got 2n squared times by a half is going to be n squared. Then I've got n plus 2n is going to be 3n times by a half, so 3 over 2n. We've got 1 times 1, which is 1 times by a half, is just a half, plus 9 over 2n plus 9 over 2 plus 3. So I've just got the n squared there. Sorry, this shouldn't be times, it should be plus. Okay, so I've got 3 over 2 plus 9 over 2. That's the n's, and that gives me 6n. And then I've got a half plus 9 over 2 gives me 5, plus 3 gives me 8. So this is going to be, to make it 8, 1 and 8, 2 and 4. 2 and 4 are going to give me the 6, so that is what I want. Okay, so just double checking, n squared 4n plus 2n is 6n, 2 times 4 is 8. So 1/3 n plus 2, n plus 4. So that is part A done. Now moving on to part B, we've got between 19 and 40. Okay, so it's going to be r equals 19 and 40, r squared plus 3r plus 1. So this now has got to be between 1 and 40 minus between 1 and 18. So this is 1/3 times 40 times 42 times 44 minus 1/3 times 18 times 20 times 22. So this is 24640 minus 2640, and that is 22,000. And then going into my calculator to just double check it, and always double checking these, the numerical ones, because you can do that, That's between 19 and 40, and there it is, 22,000. So we're good to go on question 2. Okay, part A. So this time we've got it between n and 2n of r cubed. So set this out like this. R cubed is 1/4 n squared, n plus 1 squared. Okay, so that's what we're looking at, but before I get onto that, I need to get it between 1 and n or 2n. So this is going to be r cubed between 1 and 2n minus r cubed between 1 and n. Sorry, between 1 and n minus 1, isn't it? Okay. So that is 1/4. Now it's n squared, so 2n squared. and then it's n plus 1 squared, so 2n plus 1 squared, minus a quarter, and then it's, oh sorry, just noticed my squared is on the inside there, just rub that out. So n minus 1 squared plus n minus 1 plus 1, so n minus 1 plus 1 squared, which is just n squared, isn't it? So we got a quarter, 4n squared, 2n plus 1 squared, minus a quarter, n minus 1 squared, n squared. Okay, now we've got 3/4 n squared up here, so that's what we're going to go with. Cross out the 4's here first. So we're taking out 3/4 n squared. So if I take 3/4 out of 1, that'll leave me with 4/3. And then it's 2n plus 1 all squared, so it's going to be 4n plus 4n plus 1 minus. Now if I take out 3/4 out of a quarter, this is going to give me 1/3. N minus 1 squared, so that's n squared minus 2n plus 1. Okay, and you can just double check them. So 3/4 times 4/3 gives me 1 n squared. 3/4 times 1/3 gives me 1/4, and there's my n squared. So that is 3/4 n squared times 16n over 3 plus 16n over 3 plus 4 over 3 minus n squared over 3 plus 2n over 3 minus 1 over 3. Okay, I'm just going to make a little bit of room. So 3/4 n squared on the outside. Then we've got 16 over 3n minus, oh sorry, that's n squared. 16 over 3 n squared minus n squared over 3. So that's 15 over 3, which is 5n squared. Then we got 16 over 3n plus 2 over 3n. That gives me 18 over 3n. So that's going to be 6n. And then we got 4/3 minus 1/3. So it's going to be 3/3 or 1. So 3/4 n squared. Now this is going to be a 5n plus something and an n plus something. I'm thinking they're both 1 because there's 1 at the end. And then let's double check it. So 5n squared, 5n plus n is 6n, and that's plus 1. It's just written the other way around, so I just write it the other way around. N plus 1 and 5n plus 1. So there we have shown that for part A, and now for part B we need to solve. I'll carry on here. So r equals 30 60r cubed. So n is actually 30, isn't it? Okay, because it's n and 2n. 30 and 2 30s are 60. So I'm substituting 30 into this. So 3/4 times 30 squared times 31 times, now 5 times 30 is 150, so it's 151. So putting that all in my calculator, this is what I get: 3151 59675. And then that is r cubed between 30 and 60. So 3159675. So again, you know, we've checked our answer, so we know we're 100% right on this one. Now, fourth and final question. So show that equals that. So show r equals 1 to n, where r plus 1 squared. So that's going to be r squared plus 2r plus 1, or r cubed plus 2r squared plus r. Now, r cubed is 1/4 n squared n plus 1 squared, plus 2r squared is 2 times 1/6 n plus 1 2n plus 1, and sum of r is half n plus 1. So now we've just got to expand and simplify, really. Okay, well, I'll just make that a third. So you can see that a quarter, a third and a half, you can take a 12th out as common term. And we got n squared, n and n, so we can take n out. So let's go with that, 1/12 n. So if I take out a 12th out of a quarter, it's got to be leaving me with 3. So 3n, and then n plus 1 squared is n squared plus 2n plus 1. And I've taken a third out, so that is going to be 4. Obviously no n this time, and we've got this to expand, so 2n squared. Oh, hang on, let's back up a second. Just noticed there's an n plus 1, an n plus 1 and an n plus 1. So let's also take out an n plus 1. Right, let's start again. Now I can't factorize anything else. No. So as we were, so 3n n plus 1 plus 4. Now the n and the n plus 1's gone, so that's 2n plus 1. Plus now with the half it's going to be 6. And the n and the n plus 1 have gone outside. So 1/12 n plus 1. And we've got 3n squared plus 3n plus 8n plus 4 plus 6. So that is 3n squared plus 11n plus 10. Now, if you want to kind of cheat a little bit with your factorizing, because you don't know how to factorize this, put it into your solving equations. So we got minus 5/3. Now I'll just do this in red. So we've got minus 5/3 so that's like n equals, and n equals minus 2. That means 3n equals minus 5, or 3n plus 5 equals 0, and this one n plus 2 equals 0. So these are going to be my brackets. Now it doesn't always work exactly like this because a fraction could be simplified. So when you get the two brackets, you do have to check that it matches the numbers. Otherwise it could be that it's been simplified, so you might need to multiply by a number. Okay, but now I'm just going to take it over to the side, but it's 3n plus 5 and n plus 2. So that equals 1/12 n, n plus 1, n plus 2, 3n plus 5. And just double checking, that's going to be 3n squared. 5n plus 6n gives me the 11n, and 2 times 5 gives me the 10. Okay, and I can get rid of that. So that is now part A done. Go to part B. Hence, find the missing value of n that satisfies this. Okay then. Just focusing on this 70r first. So this is 70 times. Now sum of r is a half n plus 1. So 35n n plus 1. And we want it when these two are equal. So therefore we are looking for solving 1/12 n plus 1, n plus 2, 3n plus 5 equaling 35n n plus 1. Now let's take it, I suppose we could multiply by 12, so we've got no fractions, but for now we'll take everything to the left. Okay, now we can factorize out n plus 1, and that leaves me with 1/12 n plus 2, 3n plus 5 minus 35. That's not really going to work for me, so let's go back a step and multiply by 12. Okay, so if I multiply through by 12, this is going to become 420. Right, now let's go. So n plus 1. You can actually divide by these, n and n plus 1. But generally in maths we tend to say, avoid that kind of cancelling at some point. But yeah, you could probably do that in this case. So it's n plus 1, and we've got 3n squared. 5n and 6n is 11n and the 10, minus 420 plus the 10 is minus 410. And just gonna move on to a little bit of space here. So again, just use my calculator to work out what this will factorize to, and it's going to be 3n plus 41 and n minus 10. We'll check in, so that's 3n squared minus 30n plus 41n gives me the 11n, and this gives me the minus 410. Okay, now in all of this there's only one positive value of n. So n equals 0, we can't have n being 0, wouldn't be a sum. That's going to be a minus value of n, minus 1. That's going to be a minus value of n, minus 41 over 3. This is the only one that's given me a positive value. So therefore n equals 10. Okay, and that's how you do question 4. Okay, you could have cancelled the n and the n plus 1 at this stage in this particular case, because the n and the n plus 1 were clearly not going to give you a solution. Okay, but you know, I kept it in just so that you can see, just sorting those out, and yeah, there we are. Okay, so that's this video and this small little unit on series complete.